We're going to talk about the unit circle today. This is a really good video about like where it comes from, how you use it, stuff like that. So really watch this carefully, take some good notes, and you should be good. All right, the unit circle. First of all, the unit circle is called the unit circle because it has a radius of 1. That's important. The center of it's at the origin, and that's the equation of the circle. X squared plus y squared is 1, which means if you take your x coordinate and your y coordinate, you square them, add them together, they always equals 1. There's a picture of the unit circle. Okay, no big deal. It's just a circle with radius 1. Every point on this circle, no matter what you pick, right, and you will solve that equation because it works. All right, show that that's on the unit circle. There's only one way this point's on the unit circle, and that is if you square your x and you square your y and you add them together and you get 1. Okay, so I'm going to do that. If I square this x, I'm getting a 3 over 9. If I square the y, I'm getting a 6 over 9. Guess what you get if you add those together? 9 over 9, which is 1. It's amazing. That's what's the unit circle, because the radius is 1. The points always, if you square them, they add up to be 1 every stinking time. All right, a couple of pictures here. Positives go this way. All right, if you're doing a positive angle, look at this, it's going that way. A negative angle, we go around the circle that way. Okay, so, or to get a point that way. These are called terminal points. If you stop right here at the top of the circle, I'm going to blow this up a little bit bigger. If you stop at the top of the circle right there, that point is 0, 1. 0, 1. By the way, I'm going to go ahead and start drilling this in your head. Cosine is the x coordinate. Sine is the y coordinate. Cosine is x, sine is y. Cosine is x, sine is y. Okay, if you go all the way to pi, halfway around the circle, you're negative 1, 0. So cosine will be negative 1, sine will be 0. All right, if you go that far around, it puts you way down here. By the way, that's 3 pi over 2 because it's 1.5 pi's. Remember, that was 1 pi. That's half of a pi. Down here's 1.5 pi, which you write 3 pi over 2. And look at the point, 0, negative 1, because the radius is 1, right? And so cosine will be 0, sine will be 1. We'll get to that a little bit later. And the last one, if you go all the way around the circle, you're back at 0 or at 2 pi. 2 pi is all the way, how many radians? All the way around the circle. And that's the point 1, 0. So cosine would be 1 and sine would be 0. All right, this says find a terminal point on the circle determined by each of these. Okay, the first one says 3 pi. So if I'm going to go 3 pi, here's the picture of what I did right here. Down here, I went all the way around the circle once and then halfway around again. So that's, if you go all the way around, I'm sitting here pointing at it. If you go all the way around, that's 1 pi. Halfway around again, now you're at 3 pi. Sorry, if you go all the way around, that's 2 pi. Back around, that's 3 pi, which puts you at that point right there. So the terminal point at 3 pi is negative 1, 0. The second question says negative pi. If I go to negative pi, all I'm doing is I'm going the opposite direction, negative 1 pi. So I'm going to negative 1 pi right there. What's the terminal point? The terminal point is negative 1, 0. That's the point. And the last one right here says negative pi over 2. If it says negative pi over 2, I'm going halfway to negative pi. You can see the picture right here. When halfway to negative pi, there's where I'm at. There's the point, 0, negative 1. So when I ask you what the terminal point is, it's asking you what the x and y coordinates are, sorry, at those numbers, at negative pi or positive pi. All right, here's a new one, pi over 4. Pi over 4 means you're halfway to pi over 2. So remember, pi over 2 is right there. There's pi over 2. Pi over 4 is halfway there. And there's the point. And think about it. Pi over 4 is really 45 degrees, which means, the radius is 1. That is a 45, 45, 90 triangle, which means your x and y are the same right there. That's the x coordinate and y coordinate. Square root of 2 over 2 and square root of 2 over 2 right there. Okay, here's a few more examples that you need to know, to be honest with you. If you go pi over 6, if you go to right here, if you go to pi over 6, the coordinates are square root of 3 over 2 and 1/2. And that goes back, guys, that's 30, 60, 90. Pi over 6 represents a 30-degree angle. That's why those numbers are like they are, because it goes back to that 30, 60, 90 triangle. Just like the pi over 4 is square root of 2 over 2, that goes back to the 45, 45, 90 triangle. Like if I'll draw that in here, I'll try to anyway. If I draw that triangle in here, you got square root of 2 over 2 here, You got square root 2 over 2 here, and you got 1 there. The radius is 1, right? So that's why that works. And pi over 3 is really a 60-degree angle, so what happens is the pi over 6 coordinates just switch for the pi over 3 coordinates because it's the same triangle. It's 30, 60, 90 triangle. It's just a different angle, okay? And then pi over 2 is at the top. It's the 0.0110. You need to kind of commit these to memory. I'm being honest with you. You need to commit all these to memory, and pretty soon you'll have the whole circle. Okay, doing the same thing. Terminal point, negative pi over 4. So a negative pi over 4, which puts me down here in quadrant 4. In quadrant 4, the x is still positive, but the y would be negative. So there's my point for negative pi over 4. It would actually be positive square root 2 over 2 and negative square root 2 over 2. Whatever the pi over 4 is, it's the same all the way through the whole circle. This one says 3 pi over 4. What I mean by that is your x and y coordinates are the same, except for the signs that they have. Okay, this says 3 pi over 4. It goes all the way to here to quadrant 2. And it says what's the terminal point? It's still square root of 2 over 2 and square root of 2 over 2 because it's pi over 4s. But because it's in quadrant 2, the x is negative and the y is positive. So that's the terminal point. One more here. Negative 5 pi over 6. So you start here at 0. You go to negative 5 pi over 6, which is right here, which is in quadrant 3. These are the coordinates for regular pi over 6. So those coordinates are still the same. It's still square root of 3 over 2 and 1/2. But it's quadrant 3. And in quadrant 3, x and y are both negative, so your terminal point would both be negative right there. All right, so bottom line is, every pi over 6, those are going to be your coordinates. The only difference is going to be signs. Every pi over 4, these are going to be your coordinates, except the signs are going to be different depending on what quadrant you're looking at. All right, reference number. Let t be a real number. The reference number, they put a little t bar, is the shortest distance along the unit circle between the terminal point and the x-axis. So it's the closest you can get to the x-axis. Now I'll draw you a picture here for some of these. The first one says 5 pi over 6. If I were to go 5 pi over 6, that would put me almost to 1 pi. Like pi's there, so 5 pi over 6 would be about right there. About right here. There's my terminal point. Now, the question is, how far away is that from the closest x-axis? Like, how far is it to the x-axis right there? And the answer is, it's pi over 6 away, because if I did one more pi over 6, that would put me at 6 pi over 6, which is 1 pi. All right, I hope that makes sense. The second part, 7 pi over 4. 7 pi over 4 would be like, that's really 1 3/4 pi. So, 1 pi is all the way over here. 3/4 of the pi is right here. So there's my terminal point. Also, that'd be square root 2 over 2 and square root 2 over 2. But how far is it from the x-axis? Well, it's 1 pi over 4 away. Because, if I went one more pi over 4, it'd put me at 2 pi, which is where I want to be. So there's a pattern here. Look at part C. Let me move my pictures away. Part C says 2 pi over 3, negative 2 pi over 3. That's negative 2/3 of the way to pi, which is like right there. Remember, that's pi. That's negative pi also. How far away from negative pi, or from the closest x-axis? We're pi over 3 away. Okay, so here's the deal. This is a secret for the video. All right, I'm just going to tell you this. If it's a pi over 6 or pi over 4 or pi over 3, and they ask you for the reference number, all you do is drop the number on the top. That works for the pi over 3s, the pi over 4s, and the pi over 6s only. Okay, the last one here says 5.8. Now, think about this. 1 pi is like 3.14, I'm estimating here. 2 pi is like 6.28. Okay, so 5.8 is about, it's about there. Like, it's pretty close to 6.28. So how close is it? Well, I would subtract 6.28 minus the 5.8. I think that's going to give me like 0.48, and that'd be my reference number. So, again, if there's a pi in your answer, if there's in radians, or I'm saying radians, but that's coming later, and you're looking for the reference number, you can drop the top if it's a pi over 3 or pi over 4 or pi over 6. If it's just a number like that, you got to sit down and figure out how far away is it from the x-axis. That's what reference number is, how far away from the x-axis. All right, how to use reference numbers to find terminal points. 3 steps. Find the reference number, just did that. Find the terminal point notated by that bar, and the terminal point, then you got to figure out the signs based on the quadrant. So 3 steps. Find the reference number, figure out the terminal point, and figure out your signs based on the quadrant. I'm going to show you an example here. or 3 examples. All right, so we got 5 power 6. Remember we talked about if it's a 6 or 4 or whatever, you can just drop the top. Okay, so really I'm thinking, okay, power 6. Power 6 goes with this point right here. Power 6 goes with square root of 3 over 2 and 1/2. And you're going to have to start memorizing these things. Okay, now 5 power 6. Think about what that is. 5 power 6 is almost a 1 pi. So it's in quadrant 2. Quadrant 2, the x is negative, y is positive. So there you go. Just make the x negative. Part B, again, is power 4. So I'm just going to drop the top number, make it power 4. That's the reference number. All the power 4s are square root of 2 over 2 and square root of 2 over 2. 7 power 4 would be almost a 2 pi, like it's like right there, which is quadrant 4. In quadrant 4, the x is positive, the y is negative, so there you go. And the last one, negative 2 power 3. Again, you can just drop the top. There's your reference number or point, power 3. If it's power 3, the x is 1/2 and the y is square root of 3 over 2. It's just the opposite of the power 6's. Negative 2 power 3 is negative 2/3 of the way to pi, so it's about right there. That's quadrant 3. Quadrant 3 is negative and negative. There you go. It's that simple. All right, find the terminal point by 29 divided by 29 power 6. Oh my gosh. But because it's power 6, I can just drop the top. So the terminal or the reference number is power 6. And because it's power 6, I know it's square root of 3 over 2 and also 1/2. That's how that one goes. Now I got to figure out what quadrant I'm in. Here's how you do that. Divide 6 into 29. It goes 4 times. So it's really 4 and 5/6 pi. That's what that number is. Remember, that's 1 pi, 2 pi. So if I go 4 and 5/6, I go 1 pi, 2 pi, 3 pi, 4 pi. Then I got to go 5/6 more, which is about right there. 5/6 of another pi, right there. Puts me in quadrant 2. In quadrant 2, x is negative, y is positive. Got it. One more slide. And that's just a picture of unit circle. And then there's all the different signs. You should be able to look at that now and think it makes more sense. Because every power 6, look at the coordinates. They're all the same. Every power 6 has the same coordinates. They just have different signs. All the pi over 4s have the same coordinates. They just have different signs. All the pi over 3s have the same coordinates. They just have different signs. All right, so hopefully it made some sense to you today. We'll work on the unit circle all day tomorrow. Can't wait to see you. See you then.